Good morning. Today we will discuss about the components in a system. In the last class, we have discussed how to define phase in a given system. So, briefly, we have discussed three things. In the case of gas, how to decide the phase. In the case of solid, how to decide the phase. And in the case of liquid, how to decide the phase. Also, we have discussed how to define phase in case of mixture, that is solid and liquid, liquid gas, etc. Today we will define about the components in a system. Why we want to know about the components of a system? Because our ultimate destiny is to define the degree of freedom by using Gibbs phase rule. So we have already conceived the idea about the number of phases. Now we will continue our discussion about the components. So what is the definition of components? What is the definition of component? We will write the minimum number of constituents, the minimum number of constituent, the minimum number of constituents required, the minimum number of constituent required to define the composition, to define the composition of different phase in a given system, is called components, Are you getting my point? The minimum number of constituents, required to define the composition of different phase in a given system is called components. Okay, let's elaborate the example. For instance, let's take a beaker. Here, one cube of ice is kept. One ice cube is kept. So, what will be the number of components? Here, the number of component is equal to 1. Similarly, let's take another example. Here, the same ice cube is kept, but along with it, some waters are there. So, I can write here the liquid water in liquid state is in equilibrium with water in solid state. So, here what shall be the number of component? Here what shall be the number of component? There is one formula to evaluate the number of component, that is component C is equal to n minus e. So what do you mean by n? N means the number of constituents, and e is equal to the number of relations correlating the constituents, correlating the constituents. So in this case, water in liquid state is in equilibrium with the water in solid state. So if we calculate the number of components, C is equal to, here the number of constituent will be 2, because you are able to visualize two things. Though water is present, one is in the form of solid ice and other is in the form of liquid. So I will write in the place of n, that is number of constituent is equal to 2, and what is E? E is the number of relation between the two solid and liquid state. So here the relationship is the water in solid state is in equilibrium with the water in liquid state. So the number of relation is 1. So components will be 1. Here the components will be 1. Consider another case. Suppose one beaker is kept where water is in solid state, that is in cubical ice, also in liquid state and it is covered, and also their water vapors are also present. I mean to say that inside the beaker solid ice is present, liquid water is present, and water vapor are also present. So here water in solid state is in equilibrium with water in liquid state is in equilibrium with water in vapor state. So what will be the number of components? We will use the formula component C equal to n minus E. N here is number of constituents. So what are the constituents? Water in the form of ice, water in the form of vapor, water in the form of liquid. So the number of constituents will be 3. And what are the relationships? There are two relationships. Water is equilibrium with the solid state and liquid state, that is one relation. Similarly, water in liquid state is in equilibrium with the vapor state or gaseous state. So this is one more relationship. So in all together there are two relationships. So we'll calculate C equal to n minus E, that is 3 minus 2 is equal to 1. So the number of component will be, the number of component will be 1. Similarly, we can extend our discussion to the sulfur molecule. Sulfur exists in 4 phases: sulfur rhombic, sulfur monoclinic, sulfur liquid, sulfur vapor. So what we are observing here, suppose a box contains sulfur where sulfur in all the condition exist, that is sulfur in rhombohedral form, sulfur in rhombic form, sulfur in monoclinic form, sulfur in liquid form, sulfur in vapor form. So what will be the number of components here? Here we will use the formula C equal to n minus E. So in place of n, the number of constituent 1, 2, 3, 4. So 4 minus the number of relationship 1, 2, 3. So 1, 2, 3. So 4 minus 3 equal to 1. So if we will explain about the examples here in this case, whatever the constituents are present, one thing is present, water. So we can say the number of components is equal to 1. Here water exists in 3 phases: solid, liquid and vapor, but water is only one component, so the number of components is equal to 1. Similarly, in the case of sulfur is also number of components is equal to 1. But why we are using this formula C equal to n minus E? This is very relevant in the case of chemical equation. For example, ammonium chloride NH4Cl. If we are heating ammonium chloride, it is forming ammonia gas and HCl gas, ammonia gas and HCl gas. So what will be the number of components? Here phase will be solid and 2 gas constitute one phase. So the number of phase will be 2. And what will be the number of components? Number of components, we will put the formula n minus E. In place of n, what will be the number of constituents? Solid, ammonium chloride, one constituent, ammonia gas one constituent, and hydrochloric gas one constituent. So in total there are 3 constituents. And what are the equations? Only one equation correlating the ammonium chloride, ammonia, HCl. So in place of E I will put 1. So the number of components will be 2. So the number of components will be 2. Similarly, let's conclude another example. Suppose calcium carbonate on heating, it will give calcium oxide and CO2 gas. So what are the number of phases? Here 2 solids, 1 gas. So the number of phases will be 3. And what will be the number of components? Components, write down the constituents 1, 2, 3. So n minus e, in place of n we will put 3, and what are the equations? One equation. So number of components will be 2. So the number of components will be 2. With this class I am concluding the discussion here. In the next class again we will extend the discussion.